The last of the videos that I'm going to make is to teach you how to do one thing, and that is how to write a recursive rule for any kind of sequence. Now, here's the thing that you have to remember, and this is probably the toughest thing. If I talk about a sequence, and let's just make one up, easy. Let's add 2 to get from one term to the next. You remember that's an arithmetic sequence because you have to add 2, so your common difference is 2. Now, let's go back and let's talk about what term each of those numbers is. First term, second term, third term, and so on. Now, remember, if we get way out here, what term's out here? Remember, we call that the nth term. And if you remember earlier, we called that either a sub n or f of n. Now, this is the piece that I want you to really think about. Third term. The term right before it is the second term. Now, I know you're thinking, well, duh. If we talk about the fifth term, what's right in front of that? The fourth term. So, if I have the fifth term, the fourth term is the term right in front of it. The third term is the term right in front of the fourth term. The second term is the term right in front of the third term. Now, to get from here to here, that's just one more term, one more term, one more term. So, if I know this term, this one is minus 1. 5 minus 1 is the fourth term. Then the third term would be 1 in front of the fourth term. The second term is 1 in front of the third term. Now, what am I getting at? Here's what I'm getting at. What term would be right in front of the nth term? Now, let me see if I can clean this up just a little bit. Right here is the nth term. Now, what term is right in front of it? Well, if the fourth term's right in front of the fifth term, and the third term's right in front of the fourth term, and these numbers are separated by 1. These numbers are separated by 1. That means these numbers have to be separated by 1. So if this is the nth term, then this one is the n minus first term, or we would call that a sub n minus 1, only because to get from this term to this term, I have to add 1. And if I do n minus 1 plus 1, then I get n. Remember, I could write this 2 different ways. I could write this as f of n, just like I could write it as a sub n. I could write this one as f of n minus 1. Now, so what does this mean? This means if I am writing a sequence, there's the first term, the second term, the third term, the fourth term, and on and on and on as far as I want to go. If this term is the a sub nth term, then the term right in front of it is a sub n minus 1. Or I could refer to this as f of n, and the term right in front of it is f of n minus 1. Now, you have to use this idea when you do recursive rules, because when you write a recursive rule, the question is, what do you do to the term in front? What do you do to the term right before? All right, let's continue. Let's try again. To find the fifth term, well, here n is 5. So 5 minus 1 is 4. So I take the fourth term and add 2. What is the fourth term? First term, second term, third term, fourth term. The fourth term is 8 plus 2 is 10. So that tells me the fifth term would be 10. So you don't have to write all this stuff down. Here's what you think. When you see something like this right here, here's what it means. To find any term, I take the term right in front of it and add 2. Now, there's only one place that this gives us trouble. Where does this give us trouble? What if I'm trying to find the first term? Well, that's when n is 1. So 1 minus 1 is 0 plus 2. This term doesn't exist. We don't have a 0th term. So there's no way we can find the first term. So when you write a recursive rule, you always have to write down what the first term is. So in order to finish this recursive rule, I have to say what the first term is. This is my entire recursive rule for that sequence. A sub n equals a sub n minus 1 plus 2. First term is 2. Now remember, you could have written it this way. F of n equals f of n minus 1 plus 2 with f of 1 equal to 2. Now we're going to try a couple more like this, so don't freak out if you're not getting it yet. Okay. Decide, is this an arithmetic sequence or is it a geometric sequence? Well, it's arithmetic. Why? It's arithmetic because to get from one term to the next, you are adding 4. So remember what 4 is called. 4 is called your common difference. Now let's write a recursive rule. Now remember, the recursive rule says, how do I get from one term to the next? All you do is add 4. So to write our recursive rule, we say to find the nth term or any term, I take the term right in front of it and I add 4. Now you say, well, what was the first term? Well, the first term was 1. That's the entire recursive rule. So to check it, let's just pick the fifth term. We're going to let n equal 5. If n is 5, then n minus 1, 5 minus 1 is 4, plus 4. The fourth term, first, second, third, fourth. The fourth term was 13. So 13 plus 4 is 17. That tells me that the fifth term was 17. So we know that our recursive rule was correct. Now let's try a geometric sequence. Now we know this is geometric because to get from one term to the next, we are multiplying. To write a recursive rule for a geometric sequence, again, it's the same idea. To find any term, the question is, what do I do to the term right in front of it? Oh, all I do is multiply by 2. So I'm just going to put times 2. Then what's the first term? The first term is 4. There's my recursive rule for that geometric sequence. You also could have written f of n equals 2 times f of n minus 1 with f of 1 equal to 4.